You ever wonder how huge teams of developers build something massive, like a banking app or a social network, without it all just falling apart into chaos? Well, they use a blueprint, not for a building, but for their code. And that blueprint is called UML. So that's what we're going to dive into right now. What it is and how it works. So let's just start with that fundamental problem, right? How do you get dozens, maybe even hundreds of people all working on one super intricate system and have it all actually work together? Well, you've really got two paths. On one side, you have coding without any plan. And let me tell you, that road is just paved with confusion, endless bugs, and so many frustrating delays. But on the other side, you've got coding with a blueprint. And that path, that leads to clarity, real collaboration, and just, getting things done efficiently. The big difference is having a shared visual language that everyone understands. And that language is UML, the Unified Modeling Language. I want you to think of it exactly like an architect's blueprint for a skyscraper. It's not the building itself, of course, but it is the standard visual guide that every single person on the project follows to make sure the walls line up and the plumbing actually connects. It's how you map out the structure and behavior of a system before you even think about writing a single line of code. Okay, so where do we even begin? We start with the most important person in this whole process, the user. I mean, before we can design anything, we have to understand what people are actually going to do with it. So, to make this all feel real, let's pretend we're designing a simple online library system. The very first question we have to ask ourselves is, what will people do here? Are they going to search for books? Are they going to create an account? Check out a book? This is the absolute starting point for our very first type of UML diagram. And that diagram is the use case diagram. It's this fantastic high-level view, kind of like a bird's eye view, that shows what the system needs to do, but from the user's perspective. It shows us who's using the system and what specific goals they're trying to accomplish. And the really cool thing is how simple the components are. You've got actors, which are just the roles, like a librarian or a library member. Then you have use cases, and those are the goals they have, the little ovals, like search for a book. The big box that holds all those ovals, that's the system boundary. That's our library app. And the association, that's just the line connecting a person to the goal they want to achieve. Simple as that. All right, so we know what the system needs to do for the user. Now we got to figure out how we're actually going to build it. We're shifting gears now, moving from the user's story to the engineer's floor plan. Let's see how that looks. And this is where the class diagram comes into play. If the use case diagram was our high-level concept sketch, the class diagram is the super detailed floor plan. It shows the static, unmoving structure of the system, all the individual components, or classes, what information they hold, and what actions they can perform. Every single class in our system gets represented by this simple little three-part box. Up top, you've got the class name, like book. The middle section lists its attributes. That's the data it keeps track of, like a title and an author. And the bottom section lists its methods. Those are the things it can do, like a function to display its own details. It's a really neat, organized way to define every single piece of your system. And this slide shows one of the most powerful ideas in class diagrams, visibility. See those little symbols? They're basically gatekeepers for your data and your actions. A plus sign means it's public, so it's visible to everyone. A minus sign means it's private, locked away and only accessible from inside that class itself. The hash symbol is protected, which means it's visible to its family, the class, and any of its children or subclasses. And the tilde? That's package visibility, seen only by other classes in the same group. The takeaway here is that these symbols aren't just for decoration. They enforce rules about how your code can interact, which is absolutely crucial for preventing bugs later on. So far, we've got the user's goals and the system's static parts. But software isn't static, right? It's alive, it's dynamic, it's full of interactions. So the next logical question is, when a user clicks a button, how do all these separate parts talk to each other to actually make something happen? For that, we turn to a sequence diagram. This is the diagram that brings our whole system to life. It actually maps out the interactions between different objects as they happen over time. It shows the step-by-step conversation that needs to happen to complete one single task, like creating a new user account. So let's take that create new user account idea. A sequence diagram would show this exact flow of events. You'd see the librarian object send a message to the system object, which then turns around and talks to the database. After it gets a thumbs up from the database, the system creates the account, and then for the final step, it tells an email system to send out that confirmation. It's like a visual story of one single interaction, from the very beginning to the very end. But, as all these messages are flying back and forth between the different parts of our system, there's a really important question we have to ask. When one object sends a message to another, does it have to just stop and wait for a reply before it can do anything else? And the answer is no, not always. And that's the key difference between synchronous and asynchronous messages. A synchronous message is kind of like a phone call. You ask a question, and then you just wait on the line for the answer. You can't do anything else. But an asynchronous message, that's like sending a text. You fire it off, and you can immediately put your phone down and go do something else. You'll get the reply when you get it. Understanding this difference is so important for designing systems that are efficient and feel responsive to the user. Okay, we've looked at 3 totally different kinds of diagrams, and each one gives us a different perspective on our library system. So now, let's just zoom all the way out and see how they all fit together to create one complete blueprint. So here's the bottom line. It all comes down to these 3 essential perspectives. The use case diagram tells you what the system does. The class diagram shows you how the system is built, defining all its pieces. And the sequence diagram shows you when things happen, detailing the flow of all the interactions. Put them all together, and you have a comprehensive guide for building the right software and building that software the right way. But at the end of the day, you gotta remember this. UML isn't really about just drawing boxes and arrows on a whiteboard. Its real power is as a tool for communication. It gives everyone on the team, from the business folks to the hardcore developers, a common language to talk, to argue, to refine, and to agree on what they're building. It brings clarity to the whole team.
Want all UML diagrams explained in a simple and detailed way in one guide? I've put everything into an ebook covering use case, activity, sequence, class, and component diagrams, with exercises and detailed notes. You'll find it in the description. Thanks for watching.